right, let's dive right in. Today, we're talking about one of the absolute cornerstones of C++ programming, inheritance. Think of it as the ultimate set of blueprints for building cleaner, smarter code that you don't have to write over and over again.
You know the feeling, right? You write this fantastic class, it works perfectly, and then you need another one that's like 90% the same, just with a few tweaks. So what do? Copy and paste? Nope. There's a much better way, and it's the very problem inheritance was born to solve.
So that brings us right here. We're going to look at inheritance not just as some abstract concept, but as a genuine superpower. Its main mission? To obliterate redundant code. Honestly, the whole idea is pretty natural when you think about it. Look at this lion cub. It inherits all the core lion traits from its parent, right? It knows how to be a lion, but it's still its own unique individual. C++ classes can work in exactly the same way. Okay, so here's the more formal definition. It's the process where one class can basically absorb the properties, all the data and the functions of another. And the magic word here, the whole point of doing this, is reusability. You get to build on top of solid, working code without ever having to mess with the original.
To really get this, you just need two simple terms. The class you start with, the one you inherit from, is called the base class. You can just think of it as the parent. And the new class you're making? That's the derived class, or the child. Simple as that. Parent and child.
And here's what that looks like in actual code. It's the basic blueprint. You say class, then your new derived class name, then a colon. After that comes something called an access modifier. Don't worry, we'll get to that in a second. And finally, the name of the base class you're building on. And that's it.
Now, it gets more interesting because inheritance isn't just a one-size-fits-all kind of deal. C++ actually gives us 5 different blueprints, 5 different ways to structure these relationships between our classes.
So here they are, all the flavors of inheritance you can use. You've got single inheritance. That's the simple one-parent, one-child model. Then there's multi-level, which is like a family tree, grandparent to parent to child, perfect for building up features in layers. Multiple inheritance is when one class has 2 totally different parents, which is awesome for combining different sets of skills. Hierarchical is the opposite. One parent has lots of children, great for organizing things into categories. And finally, hybrid. Well, that's just a mix and match of any of the others for when things get really complex. Each one is a different tool for a different job. All right, so you've set up this family relationship between your classes, but who gets access to what? This is super important. We need rules to control which properties get passed down and how the new child's class can maybe change up some of those inherited behaviors. This table right here breaks it all down perfectly. That access modifier we saw in the syntax, public, protected, or private, is the gatekeeper. For instance, if you use public inheritance, anything public in the parent stays public in the child. Easy enough. But if you use private inheritance, everything the child gets becomes private, locked down. But here is the single most important rule of all. Private members of a base class are never, ever accessible to the child. No exceptions. They're totally off limits. Okay, but what if a child class inherits a function but needs it to do something, a little different? That's where function overriding comes into play. It lets the child class provide its very own version of a function it got from its parent. And here's a classic example. Let's say you have a general animal class, and it has a speak function. Now, you make a dog class that inherits from animal. A dog is an animal, but it doesn't just speak, right? It barks. So the dog class can override the speak function to make it say dog barks. It's still an animal that speaks, but now it does it in its own specific way. Now, inheritance is awesome, but with all this power, you can sometimes run into some tricky situations. Let's talk about a really famous one. A puzzle that can pop up in more complex designs, the infamous diamond problem. So what the heck is it? Well, the diamond problem is a very specific issue that happens with multiple inheritance. It's this confusing, ambiguous situation where a class inherits from 2 parent classes who themselves both inherited from the same grandparent class. And you can see exactly why it's called the diamond problem from this diagram. You have class A at the very top, then B and C both inherit from A. And then, at the bottom, class D inherits from both B and C. See the diamond shape? The problem is, if D needs something from A, which way does it go? Through B or through C? The compiler has no idea what to do. And here is what that mess looks like in code. Class D pulls from B and C. If A has some function, and B and C both have it, which version does D end up with?
The compiler is completely stuck. It sees two different paths to the same thing, and it just gives up. That's a compile time error waiting to happen. But don't panic. The folks who designed C++ were pretty smart. They saw this problem coming from a mile away, and they gave us a really elegant tool to fix it.
And the solution is one simple but powerful keyword: virtual. When B and C inherit from A, if you tell them to do it virtually, you're sending a message to the compiler. You're saying, hey, I know this base class might show up a couple of times down the inheritance chain, but I want you to make sure that the final child class, our class D, only gets one single copy of A. It basically collapses the diamond and the ambiguity just vanishes.
Okay, last topic, and this one is super practical. Let's talk about constructors. When you create an object from a child class, a bunch of constructors get called. But in what order? There are rules for this.
So here are the 4 key rules you gotta know. Number 1, and this is the big one, the parent's constructor always runs before the child's constructor. Number 2, if the parent's constructor needs arguments to work, you absolutely must call it and provide those arguments from the child class. Number 3, if you have multiple parents, their constructors get called in the exact same order you listed them in your code. And finally, number 4, constructors aren't really inherited. The child doesn't get a copy of them, they just get called in this specific order.
So let's wrap this all up. What's the bottom line? First, inheritance is your best friend for reusing code and stopping you from writing the same thing twice. Second, it lets you build these logical ISA kind of relationships that make your code so much easier to understand. And finally, yeah, it can get tricky, but C++ gives you powerful tools like function overriding and virtual inheritance, so you can handle that complexity like a pro.
We've gone through the basic idea, the different patterns, and even how to solve some of its trickiest puzzles. Inheritance is more than just a feature. It's a whole philosophy for building robust, scalable systems. So the real question is, now that you've got the blueprints, what are you going to build?